Hello, welcome back to my channel. In this video, I'm going to discuss some questions which are asked in previous year teachers requirement exam under OSSC. So, some of the selected physics question. First question is, a ball is thrown vertically upwards with velocity 20 meter per second from a building of a height 25 meter. So, actually it is saying that if this is my ground, okay, and this is 125 meter building. So I throw a ball from here to upwards. Then, so after some times its velocity will become 0. Then it will return to ground and hit the ground. And he is asking to find the total time after he release the ball or throw the ball uh, and he hit the ball. Total time it taken to complete the whole process. First, you have to find out what is the time taken. It is going from here to here. Okay. So, what is given? I have to write first. Given that for first case u equal to 20 meter per second. B as it's reach here. So here velocity will become 0. So for this case velocity will become 0 for upward motion. You have to write upward. And S is given 25. Sorry, not S is given because we have to calculate S. That was not S. So and G is given. Okay. So G is given 10 meter per second. Okay. So we just apply the one formula. That formula is V square minus U square equal to 2AS. So here we can calculate S, that is as it is going upward. So I just use minus G because gravitational force is towards the center of the earth. So it is V square minus U square by minus 2G. So if I put all these values, so answer is B 0 minus 20, sorry, to plus 20 whole square. So it will become like, so it's 0 minus 20 whole square divided by minus 2 into 10. So it's cancel out. It will become like, if I solve it will become 20 meter. So this height will become 20 meter. So if this height will become 20 meter, and so time taken to go this height is, so I can directly use this rule that V equal to U plus AT. So here is same way, T equal to V minus U divided by minus G. So U is minus 20 by minus 10. So it will become 2 seconds. So first let T what is 2 seconds going to upward. So now the total distance will become total distance. So total distance will now become, so total distance already it is 20 meter up, then 25 meter, then 20. So total it is 45 meter. So you have to calculate the time period it is taking to comes to the ground floor. So here u will become 0 because it's coming from free fall. So u equal to 0. So we just apply the formula that s is equal to ut plus half a t square. Okay, so ut will become 0. So simply t square, or I just take its t2 down, coming down, t square equal to 2s divided by g. So here 2 in place of s I just put 45 divided by 10. So if you calculate it will become 9. So now t2 will become 3. So here 3 second, here 2 second. So total time is 5 second. So 5 second is the answer, which is option D. So question number 1, which you can see, its answer is option D. Question number 1, option D, 5 second. So I'm just say next question को. Next question कहला, the position of xt graphs for two children A and B are returning from their uh, schools O to their home P and Q. So okay, two boys are returning. One from the graph you can see A is from this O to P, and B is coming from here to Q. So you can mark from the graph, it's clearly showing that B, who covers a large distance, more distance within a small period of time, which is this much, but while A taking a time longer or more. So that means it indicates B walks faster than A. So question number 2 is B walks faster than A. So next question here, question number 3. Question number 3 is, an insect trapped in a circular group of radius 12 centimeter moves along a group steadily and completes 7 revolution in 100 seconds. So 7 revolution in 100 seconds, it means its angular frequency F will become 7 by 100 revolution per second. Clear? So now it's asking angular speed. So angular speed formula is omega, which is 2 pi f. So 2 in place of pi, just put 22 by 7. 22 by 7. So it will become 7 by 100. So 7 get cancelled out. It is 44 by 100. So which is 0.44 radian per second. So which is option A. So question number 3, option A. Okay, clear? So next question. Question number 4. A bullet of mass 0.04 kg moves with speed of this much, hit a block, stopped at a distance 60 centimeter. Okay. So it enters a block and after entering it, after 60 centimeter, it will stop. So what is the average resistive force exerted by the block on the bullet? So force, to find out force, so our formula F equal to ma. Okay. So m is already given. We have to find A. For A, look, from here it is clearly, you can say that this is my U is 90 meter per second. As the bullet stops after 60 centimeters, so I can say V equal to 0. So S is equal to 60 centimeters. So I just convert into meter. It will become like 0.6 meter. Clear? So it's 0.6 meter. So I can apply the formula like the previous one, what we use, b square minus u square by 2as, or you can write 2s equal to a. So that formula I just apply. So directly I am calculating a equal to b square plus 0 minus 90 whole square divided by 2 into 0.6 whole square. So this is 90. So if I calculate this answer, so it will be like 90 into 90 divided by 2 into 0.6. So if I calculate this one, let it be in this form, meter per second square. So F is equal to ma. So m is 0.04 into our A is 90 into 90. So what answer I will get? It is in the form of minus, as it is showing negative acceleration. That means its velocity is decreasing. So which indicates that force is resistivity force that is applied opposite the direction of movement of an object or bullet. So it will become like 2 into 0.6. So if I calculate, it's nearly equal to, its value is nearly equal to 270 Newton. So which is option A. So question number 4, option A. So your next question ko, question number 5. So question number 5 is, so this one. So it is showing a batsman hits a black back of ball straight in the direction of bowler without changing its initial speed. Okay, this one is speed. We have to find out its impulse. Okay, look, this is the ball and this is the batsman is standing here. When ball is going in this direction and return in this direction, that means when it is going, let its velocity is 12 meter per second. So without changing its speed, it is given. So that's why v will become, just change its direction, so it's written as minus 12 meter per second square. So as impulse formula is j equal to, we can write its change of momentum del p. So we can write like m, because mass is constant, so b minus u. So here m, b is minus 12 into, sorry, minus 12. So here mass is given already. I have to just put 0.15 into minus 24. So if we calculate, you will get around minus 3.6 Newton per second. So which is, sorry, Newton second. So the Newton second. So which is option D. So question number 5, option D. Question number 5, option D. Okay, next question जो है question number 6. Determine the maximum acceleration of a train in which a box laying on its floor will remain stationary given that coefficient of static friction. Okay, it means saying that let this is a train which is moving. Let this is a train which is moving in this forward direction. So it is showing that there is one box is laying on it. The box is remain stationary as the train is moving forward. So this ball must move towards backward direction, but that means it's showing that it has some resistivity force which stops it to move backward direction. So we have to find that coefficient of uh, static friction. And sorry, it is given, coefficient of static friction is given. So we have to find the acceleration of the train, right? So acceleration of the train, right? So we can calculate, we can say that the force of the train is equal to frictional force. So force of train is, I can write m into g. So it will be like the normal force is it's mg. So this, sorry, ma, not g, as not g. This is mass into acceleration. Box is moving backward direction. Force is ma. So it's ma, and the force applied on this one is ma. Let it is moving in the this train is moving with acceleration a. So this one is also moving backward direction with ma. So this one will become m, and as it is a normal force, so which is in upward direction, which is equal to its weight, which is mg. So mass on both sides cancel out. So a will become mu into g. So mu is given 0.15, and g, if I take 10, so its value will become 1.5 meter per second square, which is, if you see clearly, it is option C. So question number 6, option C. So next question जो है, question number 7. So question number 7 कहला, a cyclist comes skidding, stops 10 meter during this process. The force on the cycle due to road is 200 Newton and directly opposite to the motion. How much work does the cycle on the road? So we have to find. So read the question carefully. It's asking how much work does the cycle on the road. On the road. That means here we have to calculate how much work does by the cycle on the road. So for the work done, if you know the formula, it is F dot S. So as road is not moving, so on the road means we have to calculate the work done on the road. So road is not moving. So road is not moving means its displacement is 0. So if displacement is 0, so directly work done equal to become 0. So does not matter what is the force is applied. So it's option A. Question number 7, option A. So next question जो है question number 8. Question number 8 is saying in a ballistic demonstration a police officer fires a bullet of mass this one pollute it's okay. So it's given that it's meter per second. So not this one is not okay. So first we have to calculate its what is its kinetic energy. Then it is saying that when bullet emerges that pollute or stopped pollute, its kinetic energy will remain 10%. Okay, so 10%. That means it is reduced 90%. Okay, let its initial kinetic energy initial, it is let half mu square. Just its formula. So final kinetic energy is saying final kinetic energy final. So it is 10% of initial kinetic energy initial. So I can write it is like okay this much 1 by 10 kinetic energy initial. Okay, so if I take let it's the question is asking how much it is percentage we have to calculate how much it is reduced. Okay, so speed reduced, so we have to find out its final speed. So its value will become like if I calculate its let its final speed is v, initial speed is u, initial speed and final speed is v, final speed. So if it will become like m v square, it will be 1 by 10 initial kinetic energy we have already find here 1 by 2 m u square. So half m it is cancel out. So v will become if we calculate root over of 1 by 10 into u. Okay, so you have to find change in or percentage of u or speed. So I just write del u is equal to or percentage you have to calculate. So directly I am writing percentage change in u is equal to v minus u divided by u into 100. So this is its formula. So v if you calculate this one is like I am writing directly 0.1 u minus u divided by u into 100. So if you calculate, so how much it is changing, if answer you will get, so okay, just if I calculate I will get negative answer because the speed is reducing. So speed is reducing, so that's why I can use the opposite way. So that is the formula I can change because for speed is reducing. So I just take u minus v by u. So it's u minus root over of 0.1 u divided by u into 100. So if I calculate this one, so it is like you get common. So 1 minus, so root over of 0.1 is 0.31 divided by u into 100. So you get cancel out. Its answer is if you subtract 0.69 into 100, it's around 69%. So 69% nearly equal to 68%. So it's a calculation. So question number 8 is what you say answer is only 68%, option A. Okay, clear. Next question. So next question is angular speed of motor while increased from 1200 revolution per minute so to 1320. Okay, first is revolution. Let its frequency f1 is 1200 revolution per minute. So I will convert into revolution per second. It will be like 1200 by 60 revolution per second. So similarly f2 will become like 32 by 60 revolution per second. Okay, so it is asking that how many revolution does engine makes during this time. So its formula will become, so number of revolution is n equal to theta by 2 pi. So we have to find out its angular displacement theta. So angular displacement. So for that I have formula that theta equal to omega I, initial angular speed, into t plus half alpha t square. Alpha is angular velocity. So we have to calculate omega and alpha. So first we'll go proceed one by one. Omega I will calculate from here. So omega I will become 2 pi fi f1. So it will become like 2 into 22 by 7 into 1200 by 60. If I calculate, I'll get its answer is uh, 40 pi 40 pi radian per second. Similarly, omega final, it's same formula, 2 pi f2. So if I calculate, say, put the values and calculate the same way, so it will become, I'm directly writing its answer, 104 pi radian per second. So now alpha will become, so same way, v square minus u square, it is omega final square minus omega initial square. Okay, I just apply that omega final minus into omega u plus alpha t. I will use this formula. Okay, I will use this formula. So here alpha will become omega final minus omega initial divided by t. Okay, t is given here 16 seconds. Okay, so I'll use, so 104 pi minus 40 pi divided by 16. So if I calculate, this one will become 64 by 16, which is 4 pi radian per second square. Radian per second square. So now I'll use put in the theta formula. So if I put all in the theta formula, I'll get the answer. So I need some space. So I'm making here. So our theta formula will become this one. So theta is equal to omega is 40 pi into time is 0.1 second 16 plus 1 by 2. In place of alpha it's 4 pi. In place of t square I just put 0.16 whole square. So if I calculate the whole answer, it will become like this part will become its answer is, if you calculate, it's around 1152 pi radian per second, pi radian. So I'll get theta is 1152 pi radian. Okay, this one is our theta. So after getting my theta, so n is pi by 2, theta by 2 pi, what I have written here, the number of revolution we have to find. So it is 1152 pi divided by 2 pi. So if I calculate, it's around 576 revolution. 576 revolution. So just look at the options. So I'll get option. So this one, option C, is written 576 revolution. So question number 9, it's 576 revolution. Okay, next question, Jua. So next question is question number 10. So this one is question number 10. So question number 10 is asking that the mass is given 400 kg satellite in a circular orbit of radius is given 2 re about the earth. how much energy required to transfer it into the circular. Okay, so we have to need energy. So if you know, so it's potential energy, gravitational potential energy formula, u is equal to minus g m by 2r. So mass is given. Okay, so first we have to calculate u1, so which is around minus g. M is mass of earth, so its mass is given 400, so I'll put in the last by 2 in place of r. First is 2re, so it's 2r into 2re, so it's around g capital M small m divided by 4re. So u2 will become, because we have to send it in the fourth re, 4re. So I'll directly putting in place of this one, I'm directly writing its answer minus g capital M small m by, if I put its 4, it will become 4 into 2, 8 re. So change in energy will become, so delta u, it's final, so uf minus ui, so it will become, if you put the calculation, minus g capital M small m by 8 re minus g capital M small m by 4 re, its answer after taking LCM, it's g m small m by 4 re. So now if I put all these values, so g is 6.67 into 10 to the power minus 11, and the mass of earth is 6 into 10 to the power 24 kg. We have to remember this is mass of earth is 6 into 10 to the power 24 kg. So its answer, and small m is given as 400, so divided by 4 into r of earth, radius of earth is 6400 kilometer. So 6400 kilometer. So if I have to write this one, it will be similarly 6400 in kilometer. I have to write in meter, so 10 to the power 3 meter. So if we calculate all these values, by simply calculation, it will become 3.12 into 10 to the power 7 joule, because energy is we write in joule. So which is matching with option number C. So option C. Okay, sorry, it's 9. Okay, its option is 9. So it's 9 joule, 3.12 10 to the power 9 joule. Okay, clear? So next question, question number 11. Question number 11 is saying that structural steel rod has radius 10 mm, length 1, and it 100 kilonewton force is stretched along. Young modulus is this one. Then calculate stress. So it's asking to calculate stress. So stress is, so stress formula is force by area. Force by area. So it is given unnecessary things, so we don't require. Force is directly given 100 kilonewton, so I just 10 to the power 3 newton divided by area, as its radius is given this much. It's the steel rod is just cone shape, so we have to take its surface area, so I just apply pi r square formula. So it's a circular shape, means pi r square, its formula. So pi, I am directly writing 22 by 7 into r square is 10 mm. So 10 mm, if I write in SI unit or meter, it will be like 10 into 10 to the power minus 3 meter. So if you calculate, it's 10 to the power minus 2. So I'm directly writing 10 to the power minus 2 square. So if I calculate all these, putting all these values, I'll get it's 3.18 into 10 to the power 8 into 10 to the power 8 Newton. So Newton per meter square. So it's matching with option D. So question number 11, option D. So force. So Young modulus formula is that one is different, y equal to stress by strain, but it is not required here. Strain, STRA. So I think it is you given to confusion, to confuse the student, not necessarily it is required. So next question. So question number 12, showing that The figure shows the stress strain graph material AB from the, okay, this one is the figure. So question is asking on basis of this, which one is stronger? Basically, it's showing which one is stronger. So from the graph, if you see both the graph, stress of material A is more than B. From the graph, you can clearly look its stress is much high than its. So stress of A is greater than stress of B. So we can say just before I just write that Young modulus is equal to stress by strain. So as stress is more for material A, it can withstand or it can absorb more force. It can absorb more force than B. So if it absorb more force, so it can stand more time. So it can exist more time. So its answer will become A can withstand more, or you can write A is more stronger than B. So this one is not possible because Young modulus is directly proportional to stress. So as its stress is of a material A is more, so Young modulus of A is more than Young modulus of B. So this is not possible. So none of this not possible, and this is also not, because it is stress is more for A, so that's why the answer is material A is more strong. Okay, next question, question number 13, which is saying that atmospheric pressure is given, density of water is given, approximate pressure on a swimmer 10 meter below the surface. So we know that's directly pressure below a formula is directly, so pressure below a certain uh, below of water, it's P atmospheric pressure plus it's P hydrostatic pressure. So P atmospheric pressure is given 1.01 into 10 to the power 5. So it is written by mistake, it is 10 to the power 5 into, for this one we have to apply the formula rho g h. So rho g h. So I just calculate, it's 1.01 into 10 to the power 5 plus rho is given at 1000. So I'm directly writing 10 to the power 3. G is just take 10, it is given. So H is already given here 10 meter below, so 10. So it is 10 to the power 5. So if I write, it will become like 2.01 into 10 to the power 5. Okay, so Pascal. The answer is Pascal. And another one, if you know 1 atm pressure, 1 atm pressure is equal to uh, is equal to 1.01 into 10 to the power 5 Pascal. So this much Pascal is nearly equal to 2 atm pressure. So which is 2 atmospheric pressure is another unit of pressure. So which is option A. So clear? Your next question go. So next question is saying, question number 14. So given density of water is given, seawater is given, atmospheric pressure is given, and then a depth of 100 meter in an ocean. Find the force. Force is asking below 100 meter. So same formula we have to apply, same process. So P is equal to P atmospheric plus that P hydrostatic force. So which is, for this one I have to just its value is given that 1.01 1.01 into 10 to the power 5. So for this one is that same formula rho gh. So pressure will become 1.01 into 10 to the power 5 into rho is, sorry, plus. So it's rho is given this one. So it is by mistakenly written, it's around its power is 3, not 0. So if I put 1.03 into 10 to the power 3 uh, into g is 10 into height is 1000 meters, so it is this one. So if you calculate, this one is 1.01 into 10 to the power 5. So plus this will become, if I calculate in the form of 10 to the power 5, it will become like 103 into 10 to the power 5 Pascal. So if I add both the equation, it will become like 104.01 into 10 to the power 5 Pascal. Okay. So as you know, force is equal, so pressure equal to force by area. So force is equal to, that implies force is equal to pressure into area. So I just multiply pressure, I just got 104 into 0.01 into 10 to the power 5. Its area will become, its area is given here, its area is given 20 centimeter into 20 centimeter. So I have to apply it's in the meter. So it will be, if I'm converting to meter, 20 by 100 into 20 by 100, 20 by 100. So by calculating, I'll get, if you calculate, I'll get it's 4.16 into 10 to the power 5 Newton. Okay, 4.16 10 to the power 5 Newton, which is nearly equal to option A. Question A. So question number 14, option A. So next question, question number 15. Okay, a car lift a air pressure force Fi on a small piston having radius this one and pressure transmitted to the second piston. Okay, so if I draw this type of figure 1, so it's a small piston, it's a large piston. So question is asking, this is a small piston, a car is sitting on it, put on over it, pressure will be created on it, and the same pressure will be here. So as the formula we know, so pressure on this one is equal to pressure on that one also. If I have P1 equal to P2, so I'll proceed from here, P1 equal to P2. So it is asking to find out the what is the pressure necessary on small piston to accomplish this one. So directly I'm writing P1 equal to P2. So P2 equal to, same way, if I proceed, F by A, force by area. So its force is, formula is mg, because gravitational force, area A, its radius is given, what it is, 5 centimeter, sorry, yeah, 5 centimeter. So it is a circular shape, so pi r square. So mass is given, that 1350 kg. Okay, 1350 into 9.8 is already written in that bracket. Pi is just put 3.14 into r square, means 0. Because r is 5 centimeters, so it will become 0.05 whole square. So if I calculate this one, for calculating purpose, so I'll get the answer is 186619.71 Pascal. So if I convert into in this form, it is like 1.8 into 10 to the power 5 Pascal. So which is nearly equal to this one. So answer is option B. Question number 15, option B. So next question, question number 16. So question number 16 is saying, okay, here is the figure is in the down. So okay, so it is saying a block of area 10 meter square is connected with 0.1. So basically its figure is this one. So it is saying that this one is block, this one is area, mass of 0.1 kg is here. So if you look properly, its answer, question is asking that. So question, where is the question? Just okay. So it's asking a metal this one and this one, mass is this, and a liquid with placed block on table. When release, the block moves right with a constant speed 0.85. This one, that means that block which is shown here, this will move in the right hand side with a constant speed. Then what he asks? He asks, find the coefficient of viscosity of the fluid. Okay, so we have to find coefficient of viscosity of fluid. Okay, so if you know the formula of coefficient of viscosity, for that I have to find force. So force F is equal to eta A into dv by dx. So here eta is the coefficient of viscosity. So I just write A eta equal to F into dx divided by A into dv. So here dx is the distance it's covered, dv is the rate of change of velocity, or you can say simply here we can take velocity. Force we just take m into g. So if I put all these values, f equal to mg. So m is given here this one kg. So 0.01 kg. So I just write 0.1. So 0.1 into force is mg. So m into g is 9.8 into dx. Dx how much it is moves. So from the question you can see clearly it is written that it will move. Okay. It is given that 0.03. So by mistakenly it is not printed in the question. I think, but so it is not by mistakenly not printed in the question. It is somewhere it is missed. Okay, dx is given in the question. So dx is 0.3 millimeter, which I have to apply 0.3 into 10 to the power 3 minus 3 meter. Okay, divided by area is already given 0.10, and that speed is given 0.085. So if I calculate this one, its answer will become uh, eta equal to it's 3.45 into 10 to the power minus 3 Pascal for Pascal. Okay, into second, Pascal into second. So 3.45 into 10 to the power minus 3, which is nearly equal to this one. So 10 to the power 3.46 into 10 to the power minus 6 Pascal. Okay, next question here. So question number 17. So question number 17 is saying that the terminal velocity, it is saying the terminal velocity of a copper ball of radius 2.0 mm falling through a tank. Okay, this one is given. Okay, so we have know that terminal velocities formula. If you know, it's Vt equal to 2 r square g into that copper minus that density of that oil where it is going through, divided by uh, 9 eta. 9 eta. So this one is the uh, coefficient of viscosity. We have to calculate this one eta. So I can write eta equal to 2 r square g whole into density of copper ball minus density of oil divided by 9 into terminal velocity. So this will become, if we calculate, 2 into r is given, that radius here 2 mm. So 2 mm means 2 into 10 to the power minus 3 square into g is 9.8. 9.8 bracket. So rho you have to given that copper density is given here 8.9, and oil density is given 1.5. So I'm directly writing 8.9 minus 1.5 10 to the power 3. I just take outside as common. So divided by 9 into its terminal velocity, which is given 6.5 centimeter per second. 6.5 centimeter, I just take 10 to the power minus 2 meter per second. So this one is 6.5 centimeter per second. So if I calculate this one by using a calculator, so its answer will showing that which is nearly equal to 0.99 kg per meter second. So which is option A. So question number 17, option A. So next question jiba, question number 18. So question number 18 is asking that we have to find speed of, so this is right, RMS speed. So by mistake it is written RMS speed. Yeah. With two material is given, we have to find its RMS speed. Okay. So VRMS, if you understand, its value is 3 kT. Sorry, you can write kT or RT, gas constant, by capital M, which is molar mass. M is molar mass. So which is if I all these are constant. So if I write RMS is inversely proportional to 1 by molar mass. 1 by molar mass. So it's two material given. And we have to find its ratio of VRMS. So we'll proceed according to that. VRMS for argon material, for V for chlorine. So if I take, it will be like M for chlorine divided by M for argon. So V chlorine is given here. Molecular mass of chlorine is 70.9. So I just put here 7.70.9 divided by its molecular mass of this one is given 39.9. So 39.9 root over. If you calculate this one, you will get around root over of 1.77. So which is, if I go calculating, so whose value is nearly equal to 1.33. So from option, if you see 4 is to 3, 4 by 3, which is 1.33. So option D is the correct answer. Question number 8, option D. So question number 8, option D. So 19 number question, next 19. So it is saying that which we have to match which one is correct or which one not. So it is given that sine omega t into cos omega t is a non-periodic function. So it's if you know, periodic function is saying that a function is said to be periodic function if it is f of, after some time t, it will return to its initial position f of t. We can say it is a periodic function with time period t. So I just using this one. If you know sine omega t plus cos omega t, if I proceed this one, sine omega t into cos omega t, I just multiply root 2 here. So root 2 into 1 by root 2 in the inside. So it will be like sine omega t into 1 by root 2 plus cos omega t into 1 by root 2. So in place of 1 by root 2, I just put its root 2 sine omega t into cos pi by 4 or 45 degree. Similarly, it's plus cos omega t. In place of 1 by root 2, I just put sine pi by 4. So its formula is root 2. It will become sine a plus b, sine a into cos b plus cos a into sine b. It's sine omega t plus pi by 4. So his will become a periodic function with time period or period 2 pi by 4 omega. So it is a periodic function. So first one is wrong. So it is a periodic function. So second one, for second one, if you know sine omega t is a periodic function whose time period t is equal to, if you write, it's 2 pi by omega, 2 pi by omega. So second one is given cos 2 omega t, which is also a periodic function with time period, because all the sine and cosine functions are periodic function with period of 2 pi by omega. And the last one is sine 4 omega t with time period. If you know, it's 2 pi by 4 omega. So that means all are periodic. So we have to take its LCM to get its whole time period. So all the function, if I take its LCM is 2 pi by omega, which is the periodic function. Okay, now I can say it is a periodic function. It is already written also periodic function. So this one. So as we know, exponential and logarithm is not periodic. See, these are non-periodic functions. So it is written non-periodic. That means it's correct. So this is written periodic. So this one is wrong. So only option 2 and 3, which is option A. So 2 and 3 is correct. So which is option A. So last question of this series. I know this video will become very long because all the questions I have taken are calculating. Okay. So it is given that a body of oscillating SSM according to the, okay, this one is given and t is given, we have to find the acceleration. So if you know, for SSM acceleration formula is if minus omega square into x. So here x is given, I just put in place of t 1.5 to calculate its value. It will become like 5 cos uh, 2 pi into 1.5 plus pi by 4. So it will become like 5 cos, it will become 3 pi plus pi by 4. So which is 3 pi. If you know 3 pi formula, it will become like, this is formula, this is pi, 2 pi, and this is 3 pi. So it will become minus 5 cos pi by 4, which is value is root 2. So its answer is minus 5 by root 2. So x value I just get minus 5 by root 2. So I just put here, omega is already given. If it is written in the form of kx minus omega t, so this one will become its omega from the question. So omega, what I from question, it is written 2 pi. So I just put here minus 2 pi whole square into minus 5 by root 2. So minus minus become plus 4 pi square into 5 by root 2. So if I calculate its value, for it will become 2 root 2, that means 10 root 2 into pi square, means 3.14 whole square. Then put the values of pi, because root 2 is 1.414. So if you calculate, you will get answer is 140 meter per second square. So which is option A. Option A for the last question, question number 20. So I know this video become very long because all are calculative and very selective for both CPET and also for LTR. Thank you for